automated testing and how this can improve your development, and especially if you do web development. And this is actually important to learn about it, and I'll tell you briefly how did I get into this area and how I started to build my own testing framework. So at first, when we think that software test automation is something that should do only QAs or people specially trained to test the software, it's probably a wrong approach, because I'm a web developer. And I wanted to make my code better, my programs to be more stable. And at one point, I just figured out that I don't trust my code and my projects enough when they are not tested. And if the projects are changing pretty fast, it's really hard to find out, do they work now? Or if I change this line, is it working after it or no? And this constant changing is really madness when you deal in rapidly growing projects like in startups. And once, when I was working in a US-based startup, we had this problem that after some fixes, we deployed our new version of software, and we've seen the issues, bugs everywhere, and I started introducing tests into my project. At first, management was skeptical about it, but then, as they said, this saved them, saved the project for some times, and actually, at one point, CTO approved my idea. And that's how I understood that I can write tests, I can improve my projects, I can bring a better software, and not to see the blank screen on the website after new deployment done. So this is the story how I started actually as a web developer to do software testing, and discovered that there are software testing frameworks, and I can work on them and improve them. So first of my testing framework is Conception. It's built for PHP. So if you ever develop software in PHP, so PHP is not so bad as you can imagine, but it's still alive. It's very good, and there are lots of PHP conferences, even in the US. Yeah, so Conception is pretty good, but today I'll focus on CodeceptJS, which is
okay? Yeah.
Which is also pretty fine today. And yeah, let's go from this slide about me, where I just told some my story, and let's see where I am now. Right now, I am live streaming from Ukraine. I'm just pointing that it's a late night today, and it's really nice to broadcast this over ocean. And yeah, hello from Ukraine, everyone. And
welcome New York.
Okay. So as I described myself as a developer passionate about testing, I really hope every one of you as a developers, as a software engineers, will be passionate about testing too, and I'll try to add some valuable points into this idea by this talk. So if you don't feel that tests bring joy to your life, don't do testing. Really, just because maybe you are doing it wrong, or maybe you are misguiding some patterns. But at first, test should be simple to read, understand, write, and because yeah, tests are just stability barriers around our code. So they do not bring any business value by their own. but they are following the business values of our project. So if a business have some high priority scenario, like checkout process in e-commerce, or sending email in Gmail, or such processes definitely needs to be tested before they go live, and real user may encounter issues in them. But you should focus on business priority tests. So Mike makes them with takes this priority is important, and make simple tests, so they will bring you joy to your development process. So let's introduce some terms like testing, and there's manual testing and automated. Definitely we won't talk about manual testing because, yeah, we know the machines will overtake our jobs, and all the humans' jobs will be taken by AI. And yeah, automated testing can take human jobs, but actually not really. So we still need manual testing for checking the issues on that are really hard to find, some misguiding patterns, or some unpredictable results. So we still do manual testing, even if we have machines and we have everything automated today. We still do manual testing because humans can explore our software and fulfill how the requirements are fit the actual application. So when we talk on automated testing is pretty stupid because it don't bring any assumptions. It just tests that this is a scenario. If we open this web page, and if we do some actions on the site, so and this scenario should actually check the user behavior. If you start writing more scenarios of how user interacts with application, so if it is a blog, can user create a blog post? Can it update it? Can it write a comment on it? And so on and so on. You can be confident to add new changes into the software. So if you have all these patterns tested, you can update some parts of the system and then rerun the test again to check if your change really didn't break anything in the system. So anytime you do any change, you see if current state is still stable. So by using automated tests, you have a snapshot of your system at each stage. So you don't need to guess about your code. So this is a very good idea and brings you more confidence and in your professional skills. And very important to know that there are different ways to test the system. I don't like the abstract term system here because I want to bring some real life examples. So I will put some cases from web application development, as I'm a web developer. So, okay, I will do that, but here is some other points that we need to be considered. So let's go by these points very fast because I probably walked through about them, but still. We do testing which is pretty obvious that what we want to know is that software works as expected. And yeah, there are some requirements to our software, and there are some bugs in our software, and we do not expect such bugs. So what we want that software should fit the requirements. We also test to discover bugs in the software. We also test that our software is as fast as we think, and we search for security issues. We make such tests automated to execute them at each time we need them to. But bringing back to the idea that there are manual testing and automated testing, not all tests can be automated. As I told that automated tests are very stupid, and actually there are no machine learning right now in this area, and no AI, so it can just try current scenario. So it can't discover new bugs. This is very important idea. It can only test that previously found bugs, and fixed bugs won't appear again. So, and
sorry, I'm going to interrupt for just a second.
Yeah.
So to understand the difference between automated and manual testing, it's like a person driving and a car using a computer to drive. When a person is driving, they're smart. They can react to situations on the road, but it takes work. And when a computer is driving, it's stupid because it can only do what it is being taught to do. But it's easier because it's being done for you. So, Michael, please continue.
Yeah. Okay. So I think the computer driving car is also very smart, unlike our automated tests. But yeah, thanks for the point. We also can do performance testing to check that just run over 100 or 1,000 users on one web page and see if there are some regressions in it. This can also be automated. It's pretty stupid scenario. It's really not hard to implement. And the next case is to seek for security issues. You really need some white hat hackers to check your system for security. And because a software is stupid, it can't hack your site by its own. So you need qualified engineer to test this. So you see, we still need manual testers. We still need automated testers because we can't delegate testing that software works as expected to manual testers. We can't ask a real person to recheck all the possible scenarios of user interactions on every code change we do in our software. So probably you can hire like 1,000 people and they will reclick everything, but because of human factor, this won't be very reliable. So this is why we use automation in such cases. So yeah, and because we actually software engineers, let's automate these things, yeah. So we do automated testing to establish trust. We do it because our code base is constantly changing. And what we want to do is to be confident in our code base. Some cases where we don't do automated testing. So when we are running really, really fast, so it's like startup and we need some money into this startup and we need features delivered really fast. So we don't have time to think about how to stabilize everything because everything is very unstable. So maybe today we will receive money, maybe we will not, maybe we will drop the startup and move to other startup, maybe we'll do pivot. So if automated testing is really important when you work on stable but growing project. If its project is not growing, well, okay, we won't. It's okay how it is. So, and if you can't convince your management that you need to spend some of your time in automated testing or hire dedicated engineer to automated testing, and its manager is absolutely unconvincible. Yeah, that happens, I think, still happens. Okay, don't do it and search for a better job. So that like different levels of automated testing, and we call them unit testing. I think this is the most popular term right now. Acceptance testing, functional testing, end-to-end testing. There can be a bit confusion in these terms, but let's see that each system, I will bring the word system again into this talk, because right now I want to talk about some abstract software. Each system can be tested from the inside and from outside. And if we test the system internally, we know how the processes work in it. But when we test it externally, we test how user actually sees it. Concentrated on the box. Let's assume that inside the box there is a chocolate factory, and this hole in this box is a user interface. If I put my hand into this user interface, I should grab a chocolate. This is expected behavior from the point of user. I take a chocolate and wow, I'm happy I have a chocolate now. So from the user perspective, if I put my hand into it, I take a chocolate, this is a good scenario to be tested. So, but this doesn't test that chocolate factory inside the box actually exists. And because I can just put some chocolates in it and user will be happy, but no chocolate factory is out there. So we need to test the chocolate factory out there in this box actually functioning. So it can create chocolates, and user, by using its interface, can take chocolate and eat it. So without any of these tests, the overall scenario is not complete. Yeah. So let's see how it's taken into the software automation terms, that there are unit tests, integration tests, and acceptance tests. So some of such tests are executed from the outside of the system, some of them from the inside of the system. Because there are different kinds of software and different ways to build it, write it, we won't talk about this internal level, because it's really a deep forest, and we will probably get lost there as we will dig into the code. But let's talk about the user interface testing, because if we do some software development, we do it for users, and we always check from eyes of a user how we interact with the system. So especially if we do web development. So if we do web development, our product is some web page, web application. We always need browser. We have HTML, CSS as interface. So it's pretty straightforward. How should we test it? Just as we actually work and interact with web application. So when we start acceptance testing for the web, we start automating what our users actually use how our users use the website. We try to go with business critical scenarios like logging in, register, restore password, some, I don't know, checkout for e-commerce, as I was told. And what is pretty important here is that we check the interface here, that all the interface elements are working. So because system can work from the inside perfectly, but because someone forget to put the button on the page, user won't see it and won't be able to use it. So we are focusing on UI. And if we go to web applications, there are pretty much of things we can test from start. Composing emails like on this Gmail screenshot, sending emails, receiving emails, just go and try these buttons to click, to fill fields, and so on and so on. So using all the elements on this web page and following the business scenarios. So to start testing a web application, we should consider how we interact with this page, how we find active elements on this page, what will we check on a page, and how to make this effective, and how to, in the end, to execute such tests, because yeah, we will probably need a browser to run them. So let's go to from the last question. I will just show you a very scary slide, this one, that there are different ways to run browsers today. And you can control browsers, and there are lots of tools to do it. So when you start to investigating, probably after this talk on your own, how to do browser testing, you will find out that there are pretty much of the tools you can try to use, but don't hurry, don't try to go with them, because it really doesn't matter, and it's not a really big deal how you control browser. It really matters how you write the scenarios. So at first, to interact with the web page, we need to open it. We need to do some actions. The most common are click, fill text fields, click again. What we actually check that there are some texts on a page and it actually exists. So after creating a blog post, we see that since the blog post was created, and we check that it's actually published on another web page. So we check its URL, we check its text, that the blog post text contains the text we put in previously. Sometimes elements do not appear on time, so that something is rendering or a JAX request is sending. So the web, as we know it today, is very asynchronous. So we can't predict is the page rendered or not. So sometimes we will need to wait for elements or for text. So we will need to put such triggers into our tests too. And we check for the text visibility for some elements that appear or URLs, and waiting for such elements, yeah, which I was already mentioned. So this is where CodeceptJS is. Oh, by the way, I forgot to mention one thing that is absolutely important to mention here. So when we check something on the website, and we're trying to check it as an actual user, we don't have user eyes. So by checking the visibility, we can see that, hey, there should be a blue button on a page. No, we will probably tell the system that there should be a button. This button class can be blue. The button text should be as we defined, but we can't test that. So we should put very straightforward requirements and textual requirements. So sometimes we can do visual testing. There are tools to do visual testing, but it's not such important for business scenarios to do it. So we will focus on textual information when we do this checking. So we are like testing like a real user, but because we are stupid software machine, we can't test it just like regular users do. So here I'd like to introduce the CodeceptJS, a tool which simplifies testing. And if you are going to improve your software as you do it, you can use CodeceptJS today to start writing tests, because it's very, very simple. It's end-to-end testing framework. End-to-end is another name of acceptance testing, so just feel free to use this term. So it's pretty the same. It can execute your browsers in different ways. You remember that slides where there were different ways to execute browsers, and CodeceptJS can do it. And we are checking websites as a real person, and we are focusing on the test scenarios, and we don't really care how the browser will execute it. So here is a scenario, one simple test of in CodeceptJS. So those of you who are software engineers, or even not software engineers, everyone can read this code. This is JavaScript, so it's absolutely valid JavaScript code, but it's written in very simple, straightforward manner, so everyone can read it. So just, I am on a page, so this command opens a page, then we wait for some element on page, then we check visibility of element, filling field, and so on and so on and so on. So without any technical skills, we can easily read this test, and it's really simple to write such one. So when we have this
if you were to not use CodeceptJS and you were to use straight up Selenium, you would have at least 3 or 4 times the amount of code, and be very low level. So this essentially, each line here provides a shortcut for a whole bunch of Selenium code.
Yeah, that's right. That's right. So because we don't care how it is executed, and right now we don't even need to know what Selenium is. The idea is that we are writing a straightforward actions of just as user would write what are they doing on the website. So, and this is how it is executed. So it actually opens a browser, it puts some things into it, and it checks for the result. So very simple, very fast, and yeah, and you can introduce it very without any problems. So you will get problems afterwards, but that's another topic. So the test was written in JavaScript. It's very simple to read by anyone, and because of simplicity, it's really simple to introduce new tests, update current one, and the code is always clean. So here is the point. When we do testing, we should always focus on the scenario, on test scenarios, how our user sees it. So there's implementation, so how actually browser is controlled, what it actually do. And this shouldn't be a really big point of our interest, because we follow the business scenarios. Because we follow business scenarios may change, may be improved. So our test should be updated as well. So if we replace some buttons or we introduce some new steps into the checkout process, the test should be updated. And because of this idea, the test and the code which actually executing test should be separated. So focus on test, focus makes it simple to read and write. And because we are focusing on this, we don't tell how to execute this browser. We can execute this browser in a window. We can execute this browser without opening a window. In Chrome, in Firefox, we can use a WebDriver API with Selenium. We can use Puppeteer, or there are just different tools to control browsers. And we didn't specify one when we were writing the test. We can configure it afterwards. So what we get if we do automated testing, and especially if we do it with CodeceptJS. So we get clear and simple acceptance tests. So developers and QAs understand what is tested, what is not, how it can be improved. We don't delegate testing to some outer team. We can handle it by ourselves. We can work together to make testing better. And we can check that software, how software is developed, and at every point we can rerun a test. If a test is failing, we can easily fix it. So yes, and a few notes to summarize my talks. That at first, if you are a developer, you need to do software testing, because you won't be sure of your code until you test it. The system or your code, better to say it right now, can be tested both from outside and it's from inside. From inside, you do unit testing, integration testing. It's very good practices, TDD. You should learn about them, write testable code, test it. But still do not forget about your users, about how they see your software, and do testing from the outside. And if you do a web development, use CodeceptJS to test your application from eyes of your user. So thank you.
Thank you, Michael. Do I have any questions? Then I have a question. Who can define what it means to test? What is your definition of testing?
Definition? Oh.
Michael, I'm not asking you. I'm asking people here.
Okay, cool.
For me, testing is like essentially means that you're essentially making sure the code you write just runs as efficient and effectively as possibly can, right?
Doesn't necessarily have to do with code.
I guess you can talk about a high level of the application as well. The whole ecosystem is just performs well. Everything from top down.
Okay.
You test whatever, the most important parts, I guess you test them to make sure they work properly. But
yes, there are different types of testing. There's functional testing, there's performance testing, usability testing, security testing. There are other types that I don't even remember right now. But basically, testing is the process by which we compare what is with what should be.
Sure.
And then whenever there's a discrepancy, we try to bridge that gap.
Right.
So, any more questions? No?
But it's the same concept across all different platforms and languages, right?
Yes. Yeah. The concepts of testing are not even specific to software.
Right.
You could be testing food.
Sure.
Testing involves a scientific experiment. So you begin with a hypothesis. You perform a test procedure. As a result of the test procedure, you observe the results, and then you compare them against your expectation, and then you make a conclusion. And that applies to software. It applies to testing anything. But what's peculiar about software is that technology is very complex, and that we create it a lot of times. Yeah. Yeah. So that's where we are.